Okay, counting on with fingers to do addition. This is a skill which we've really been pushing at the minute, and it enables the children to be able to solve a 2-digit out of 1-digit. So for example, something like this: 26 add 7, or 35 add 9. Now what I'd get the children to do, and my language that I use to the children, is this. I say 26 in your head, and 7 on your fingers. That's because they're adding on from 26 and they're adding 7. The children then have 26 in the head and they have 7 fingers, and they count it down and they count up 7. So they go 27, 28, 29, 30, 31, 32, 33. And then they should be able to answer it using that. The main mistakes that children do with this is, instead of having 35 in their head, for example, they use that as their first number. It's very important that 35 is in the head and then they count on with it. So for example, 35 add 9, 35 is in my head, 9 is on my fingers, and I count on from 35. So 35 in my head, 36, 37, 38, 39, 40, 41, 42, 43, 44. So then I know that that is 44. Now I can answer that with a 2-digit and a 1-digit number. Subtracting using our fingers. This is similar to adding with our fingers, only it's counting backwards instead of forwards. So for example, if I wanted to do 32, take away 6, this is a 2-digit number, take away a 1-digit number, so I can use this strategy. 32 in my head, 6 on my fingers, and then I count back. 31, 30, 29, 28, 27, 26. Then I should be able to get that answer, 26. One more example would be 42 take away 8, 42 in my head, and I'm counting back 8, so 8 on my fingers, as you can see. And then it is 41, 40, 39, 38, 37, 36, 35, 34. So my answer for 42 take away 8, the children can work out that it's 34 using their fingers. Subtracting using our fingers. This is similar to adding with our fingers, only it's counting backwards instead of forwards. So for example, if I wanted to do 32 take away 6, this is a 2-digit number, take away a 1-digit number, so I can use this strategy. 32 in my head, 6 on my fingers, and then I count back. 31, 30, 29, 28, 27, 26. I should be able to get that answer, 26. One more example would be 42 take away 8, 42 in my head, and I'm counting back 8, so 8 on my fingers, as you can see. And then it is 41, 40, 39, 38, 37, 36, 35, 34. So my answer for 42 take away 8, the children can work out that it's 34 using their fingers. Using a 100 square to add a 1-digit to a 2-digit number. Now to solve a problem like this using a 100 square, the children have their own 100 square to use, and they also usually have a whiteboard pen. They're going to start on this number, and then they're going to use jumps to add this number. With this problem, you need to circle first a 2-digit number, and then they need to do 8 jumps. 1, 2, 3, 4, 5, 6, 7, 8. The only where this can go wrong is when they have to jump over from a 50 to a 51. They need to remember to count that jump. Okay, I'll show you now with another problem. So, for example, if I was going to do 66, add 7, I would firstly have to find 66 in the 100 square, then do my 7 jumps, which looks a little bit like this. Here's my 66, and now I'm going to jump 7. 1, 2, 3, 4, 5, 6, 7. And then you should be able to get their answer by jumping to the right. Taking a 1-digit from a 2-digit number with a 100 square. This is exactly the same as using addition with a 100 square, except for they have to go to the left instead of the right. I'm going to show you an example of this now. So firstly, they have to find 68 on the 100 square, because that's the number they're taking away from, and then they jump back. 1, 2, 3, 4, 5. So with 68, take away 5, they'd be able to work out the answer is 63. Subtracting using a 100 square over the 10 boundary. Now this is a problem because it involves moving from one side of the 100 square to the other, but it's still the same in that they have to jump to the left. So for example, for 73, take away 6, the children would firstly find 73 on the 100 square, and then they will count backwards 6. 1, 2, 3, 4, 5, 6. And they should be able to work out the answer from that. So my answer would be 67. Adding using a 100 square, adding a 2-digit number to another 2-digit number. Now this involves them doing 2 moves on the 100 square. When they're using the 100 square, they should know that if they move down, they are adding 10 each time, and if they move up, they are taking away 10 each time. So for 47 add 25, the children would find 47 on the 100 square, and they would move down 2 to show that they've added 2 tens. They now need to add the units, so then they do the jump to the right like I've shown previously. So 1, 2, 3, 4, 5, and they should be able to work out the answer using that strategy. I'll show you one more time. If I was going to add 63 and 31, what I would do is I would go to 63 and I would add my 31. So I'd move down 3, add my tens, and then I'd move to the right 1, add my unit. They should be able to get the answer. 94. Subtracting using a 100 square to take away a 2-digit number from another 2-digit number. Now this is just the same as addition, apart from if they're subtracting tens each time, they need to be moving up the 100 square and then to the left. So I'm going to show you how to do 37, take away 19 first. I would find 37 on my 100 square. I will then take away 10, so I'd move up 1 square, and then I do 9 jumps to show my units. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'd be at 18. Okay? If I wanted to do a different problem, so for example, if I wanted to do 45, take 26, I would find 45 on my 100 square. I would then move up 2 tens, I'd be at 25, and then I take away my units. So 1, 2, 3, 4, 5, 6. I should have the answer 19 if I was doing 45, take 26. Hope that helps. Adding a 2-digit to a 1-digit number using a number line. Now this is quite a difficult problem for some of the children, but it's a very important skill to show that they need to add to the 10 before they can carry on. So for example, for 36, add 8. I have my number line, and I have 36 add 8. 36 would be here, and my first jump would be to my next 10, which in this case is 40. So I've added 4 to 36 to get to 40. Now some children can already work out that that means they have 4 to add left over. Some children still find this a bit difficult, so that's okay. We just need to say how many are we adding, which is 8. How many have we already added? 1, 2, 3, 4. How many do we have left to add? Another 4. So then I'd add 4 to make 44. So they'd be doing that in 2 jumps. They'd be going to the 10 first, and then they keep going. So they should be able to work out their answer. Subtracting a 1-digit number from a 2-digit number using a number line. Now this is similar to adding a 1-digit to a 2-digit number, only the children have to count backwards. So again, this makes it more difficult for them. This is how Flex and Flow suggests it is taught. So as I'm subtracting, my larger number would go on this side. I would then have to jump back to my last 10. So in this case, I would have to take away 2 to get to 60. Again, some children can then work out that they need to take away another 7. Other children aren't sure. So if that's the case, they put the pen down, they work out, I've got to take away 9, I've already taken away 2, so I have 7 left to take away. And then they'd have to count back from 60 by taking away 7, which would give them the answer 53. So they've done their first jump, getting from the number to the 10 before it, and then they add whatever's left to find their answer. Adding a 2-digit number to another 2-digit number. Now sometimes the children can do this in their heads by adding, for example, the tens together and then the units together. But I'd also like them to be able to do this using a number line, which is especially useful when they go over the 10 boundary, which I'll show you in a minute. So first of all, they put their first number at this end of the number line. They then jump by adding their tens first. So in this case, I'm adding 20 to 36, and they should be able to work that out. Makes 56. I then need to add my units, so I need to add 3 to my 56, which gives me my answer, which is 59. So I firstly added my tens, and then I added my units, and that should give you the answer 59. Sometimes they will have to add over the 10 boundary, which is where it becomes more difficult and where this strategy becomes even more helpful. So for example, if I wanted to do 57, add 25, I would put 57 over here. I would then, just the same as the last time, add my tens. So I'd add my 20 tens to get me to 77. And then I'd add my units. So I add my units. So they can do this one of two ways. They can do one big jump of 5, which then would get them straight to their answer, which in this case is 82. Or they can break down that 5. So they can add 3 instead to get to their next 10. And then that means they have 2 left over. So again, if they're not sure how many they have left to add, they can work out, I've got 5 to add, I've already added 3, I have 2 remaining to add. And that can give them the answer 82. Sometimes, when we're subtracting a 2-digit number from another 2-digit number, we go over what's called the 10 boundary. And this makes it difficult for the children. So this is where a number line is especially useful. So we put our number that we're subtracting from at this side of the number line. We then take away our tens. So in 27, I have 2 tens. So 52 take away 20 would give me 32. That would be my first jump. The next part I can do one of 2 ways. Some children would be able to take away 7 straight away from 32, which would give me 25. Other children would find it more difficult. So if that's the case, you have to jump to the 10 that is before 32. So I'd take away 2 from 32, which would get me to 30. That would mean that of my 7, I've taken away 2 so far, meaning I have 5 more to take away. So 30, take away 5, as I've already shown you, would be 25.